Hey, everybody, this is Steve Hughes, and we are going to spend a few minutes together going over some trigonometry and calculus for the NES Secondary Ed Mathematics exam. Once again, my name is Steve Hughes. I'm going to jump in here and have a little bit of fun with you guys today, looking at some trigonometry and calculus. Let me grab a pencil here and we're going to talk the first question through together. So let's walk through this. All right, it says, which of the following are solutions to this trigonometric equation, 2 sine squared theta equals cosine theta plus 1? And they give us 4 examples. Now, everybody, we have 2 methods whereby we can do this. One is to do some algebra and trigonometry. 2 is work backwards. Now, notice in this particular question, they give us pi in every one of these answers. Okay, so pi is not anything that's going to help us out here. What am I saying by working backwards? I mean, if I put in here 2 sine squared pi equals cosine pi plus 1. All right, sine of pi is 0. So 0 equals cosine of pi, which is -1 plus 1, which is 0. 0 equals 0. That's true. And obviously, pi is in every one of the answers. So that's not going to be something that's going to help us. We want to focus on, is it pi over 6 or pi over 3? Okay. And which quadrant is that in? So that's what we want to focus on. All right. So therefore, we're going to start by looking at some trigonometric identities. Which trig identity could we use to help us solve this? Notice we have a sine squared theta and we have cosine theta here. So we're going to use the Pythagorean identity, which says sine squared theta plus cosine squared theta equals 1, all right? Which means that sine squared theta equals 1 minus cosine squared theta, okay? Now, that being said, we're going to make a substitution. So let's do that. We're going to put 2 times the substitution, 1 minus cosine squared theta equals cosine theta plus 1. All right, let's distribute. We'll come down here where we have a little bit more room. 2 times 1 is 2, minus 2 cosine squared theta equals cosine theta plus 1. All right, let's bring everything to one side. It doesn't really matter which side. I'll bring it to the left. That's fine. Bring it to the right. It doesn't really matter, okay? So if I organize this a little bit, I'm going to have 2 cosine squared theta minus cosine theta plus 2 minus 1 equals 0. All right, which gives me -2 cosine squared theta minus cosine theta plus 1 equals 0. Make everything positive as much as you can. So I'm going to change the terms by multiplying by -1. And I now have 2 cosine squared theta plus cosine theta minus 1 equals 0. Okay, now stop right here and ask yourself a question. How can I best solve this? Okay, while you're thinking about that, I'm going to erase some of this information. All right, so we have some more room to work. All right, so what we're going to do is we're going to use a substitution method, right? We're going to say let x equal cosine theta, okay? So that means I now have 2x squared plus x minus 1 equals 0. Now I can factor this, 2x, x equals 0, okay? Now I have plus or minus 1, right? I have -1 here. I have +1 in the middle, so I need -1 and plus 1. Right, to factor, that gives me 2x squared plus 2x minus x, which is 1x minus 1. So that is spot on. All right, therefore my answers are 2x minus 1 equals 0, tells me x equals 1/2. x plus 1 equals 0, x equals -1. All right, those are my two solutions, but everybody now I must back substitute because I'm not trying to solve for values of x, I'm trying to solve for values of theta. All right, so let's do a little bit more clearing. While I'm doing this, you can think about what we're going to do next. All right, before we said let x equals cosine theta. So now I'm going to look at two situations. Cosine theta equals 1/2 or cosine theta equals -1. All right, let's take the easy one first. All right, cosine theta equals -1. That is theta equals pi, right? Theta equals pi. That's the one we already saw from the beginning, and you can see that pi is in every one of those answers. So that's neither here nor there, right? It's there. We already know it. What about cosine theta equals 1/2? Okay, first of all, it's positive. Therefore, it must be in the first and fourth quadrants, right? It must be positive, right? It must be positive, and it looks like my triangle is 1, 2, and the square root of 3, right? All right, so cosine is equal to, or theta rather, is equal to pi over 3 in the first quadrant. All right, so now everybody look down here. What do we have? Before I do anything else, I have pi over 3 because of my triangle, right? So I have pi over 3 and I have pi. So therefore, this must be the answer. I don't even have to do any more work because why? Because that's the only answer that has pi over 3 in it. Everything else is either in the second or third quadrant, 2 pi over 3, 4 pi over 3. All right, and so I'm not going to spend any more time. I'm going to find those first two answers and I'm going to be done. All right, very good, guys. Let's see what comes next. All right, next, what is the period of sine 2x? What's the key to this one, everybody? Okay, the key is to know the period formula, right? So the period is equal to the standard period, right? Whatever that is, standard period over the absolute value of b. All right, so in our case, the period equals, what's the standard period for sine? It's 2 pi, right? What's b? In this case, it's 2. So the absolute value of 2, which is 2 pi over 2, which is pi. And our correct answer is B. So the formula, everybody, is period equals standard period over B, right? For sine, it's 2 pi. Be careful, right? For the trig function you're using, be careful for the period given for that particular trig function. All right, very good. We're going to keep moving on. All right, next. We have a question about a Ferris wheel. A Ferris wheel has a radius of 20 meters and completes one revolution every 2 minutes. What is the angular velocity in radians per minute? All right, everybody, first thing we want to know is the formula for angular velocity. Angular velocity is omega, right? It looks like that W. So omega equals the angle theta divided by time t, right? That's what angular velocity is. Theta divided by t. All right. So in this case, what does it tell us that theta is? It tells us it does one complete revolution. That's 2 pi. All right. And what is time? It is 2 minutes. All right. So this is radians right here, right? Radians. And this is minutes, right? So if we cancel out the 2, we find out that our angular velocity is pi radians per minute, right? And we're done. So keep that formula handy for yourself, right? For the exam. The angular velocity is equal to the angle theta divided by the time t. So remember, angular velocity is how fast on a point, okay, how fast it's turning, right? How fast it spins. Linear velocity is how fast a point on the edge is traveling. So that's a different question. So keep those two distinct and separate in your mind. All right, very good. Next question. They give us a function. If f of x equals 3x to the fourth minus x 8x squared plus 6, what is the value of the limit of f of 1 plus h minus f of 1 over h? All right, everybody, here's the key takeaway. This is the limit definition of a derivative, right? We don't want to go through this whole process. Just remember, this is the limit definition for a derivative. So what do I really want to know here? What would expedite and make best use of my time, right? That's what I'm asking. What would make best use of my time? The best thing to remember here is that this is equal to f prime of 1. All right, that's it. So there's f of x. What is f prime of x? F prime of x is equal to 3 times 4x cubed minus 8 times 2x, all right, to the 1 plus 0. All right, so that is equal to f prime of x is equal to 12x cubed minus 16x. F prime of 1 is equal to 12 times 1 cubed minus 16 times 1, which is -4. And my answer is D. All right, that's a much shorter way to do it, everybody, than work through the formal definition of a limit. You don't want to do that. You just want to go straight to the derivative itself. All right, very good. Moving on. All right, next question says, if f of x is increasing and concave up, then if f of x is increasing and concave up, then what? All right, which of these is true? All right, so what's the first thing we want to know, everybody? The first derivative, f prime of x, describes the slope of f of x, right? So if it's positive, it's increasing. It's negative, it's decreasing. So we see that f of x is increasing. Therefore, we know that f prime of x must be greater than 0. So it could be A or it could be C, right? It could be one of those two because f prime of x is greater than 0, and they told us that f of x is increasing, all right? Now it's concave up. The second derivative describes concavity, all right? If the second derivative is positive, it's concave up. If it's negative, it's concave down. All right, this is concave up, therefore it is positive. Therefore, f prime of x is positive and f double prime of x is positive. Therefore, my answer is what? You guys tell me. You're right. It must be C. All right. So keep those things in mind. Keep in mind the first derivative, positive and negative, what it means. The second derivative, positive and negative, what it means. All right. Very good, everybody. All right, next question. A particle's position is given by S of t equals t cubed minus 6t squared plus 9t. When is it at rest? Okay, everybody, when is it at rest? What does that even mean? All right, first of all, this gives us a position function, S of t. The derivative, S prime of t equals v of t, right? And that equals the velocity. All right, S double prime of t equals v prime of t equals a of t, which is the acceleration. All right. So they ask us, when is the particle at rest? The particle is at rest when the velocity is 0. All right. The particle's at rest when the velocity is 0. Therefore, we need to know the derivative and set it equal to 0. So s prime of t equals v of t equals 3t squared minus 12t plus 9. All right. Now the question is, when is that equal to 0? So 3t squared minus 12t plus 9 equals 0. We could divide everything by 3 just to make it more simple. That gives us t squared minus 4t plus 3 equals 0. Now we can go ahead and factor this. All right. That's going to be t minus 3t, t minus 1. That tells me that t equals 3, 3, and t equals 1. All right, so that answer must be D. All right, so the key thing to remember here is that velocity is the first derivative, acceleration is the second derivative. A particle is at rest when the velocity is 0. Therefore, we take the first derivative, set it equals 0, take that function and factor it as necessary to solve for t. All right, very, very good, everybody. All right, next question says, a sum of $2,000 is invested in a savings account. The amount of money in the account after t years is given by an equation A equals 2,000 e to the 0.05 t. What is the approximate average value of the account over the first 2 years? All right, everybody, what do we want to remember? Oh, wrong thing here. Let's go there. There we go. That's better. Let's get back to the one we were working on. There it is. Sorry about that. All right. So first of all, what is it we want to know? We want to know the average value. Okay. So that's the first thing to write down. What is the formula for average value? We don't just want to find the first and second year and divide by 2. We don't want to do that. So we need to know the average value. All right. So the average value is equal to 1 over b minus a, all right, times the integral from a to b of f of x dx. Okay, that's what we want to know. All right, so let's take just a minute, everybody, and see if we can get this set up properly. Okay, I'm gonna let you think about it just a second, and I'll keep going with you guys. So give it just a moment to ponder, and let's see what we can do. All right, let's go. Change colors here for a minute. All right, we want to find our value here is for the first 2 years. So 0, 1, and 2, right? So we want to find 1 over 2 minus 0, the integral from 0 to 2, 2,000 e to the 0.05 t dt. Okay, so that's what we want to do. So making a little bit more simple here, we have 1/2 the integral from 0 to 2, 2,000 e to the 0.05 t dt. All right, let's keep going. We're going to then integrate. We have 1/2 times, what's the derivative? I'm sorry, the antiderivative, it's 2000, right? Times 1 over 0.05 e to the 0.05 t, right? 2 minus 0. And there we have it. Now we just got to plug these values in, everybody. Okay. So we can make this real simple. Grab yourself a calculator if you want to, and multiply those numbers together. 1/2 times 2000 divided by 0.05. All right, let me just grab my calculator real quickly here. All right, that is 1/2 of 2000 is 1000, right? So that's 1000 divided by 0.05, which is 20,000. All right, e to the 0.05 t. All right, that is 20,000 times e to the 0.05 times 2, right? Minus e to the 0, which is 20,000 times, grab your calculator again. Well, let's find this value. Let's find e raised to the 0.05 times, whoops, times 2. All right, close parentheses. I get 1.105. All right, minus 1. 0.015159, right? Then I'm going to multiply that times 20,000. And I'm going to get 2103.48. So the answer is 2103.48. Once again, I'm doing this minus 1. That's an estimate though, right? So you can just plug this directly into your calculator right here. Plug it directly in and you're going to get 2103, right? And some change there. So the correct answer is part A. So remember, first of all, the average value, that's the key takeaway, right? The key takeaway, then the antiderivative of e to the x, and then applying the fundamental theorem of calculus to evaluate, and then put your values in at the end. Now, you will be slightly different if you round it off, so be careful. That's why I didn't round it off specifically with the 1.105, but use the longer value where I came up with the 2103. So be careful with the rounding off of that particular answer. All right, very good, everybody. Let's keep going. All right, next question. Which definite integral represents the area between f of x equals x and the x-axis from x equals 0 to 2? First thing you want to do here is draw yourself a picture. Okay, that's the key takeaway here. Draw a picture. So let's draw our x-axis. All right, let's give ourselves a couple of tick marks. 1, 2, 1, 2. All right, and it says x goes from 0 to 2. Let's change colors. All right. X equals 2 is here. X equals 0 is here, right? And our function is f of x equals x. And it's between the x-axis and that. Let's change colors again. All right. Here's the x-axis right here in green. If I want to draw the line, I need to go through the origin. I need to go through the point 2, 2, right? That's the function f of x equals x. So let's draw ourselves a line. All right, there it is, everybody. Therefore, the region I'm looking for is the region in between the green and that last blue, right? So the region I'm looking for is right here. This is the region I'm looking for. And this area is equal to the integral from 0 to 2 x dx. And that is it, right? I don't have anything to subtract from it because it is f of x minus g of x, and g of x in this case is the x-axis. Therefore, my integral is simply x dx. So the key takeaway here is use your values that are given to you here, your function, your x-axis. 0, 2 tells you the limits of your derivative. You can set it up there, shade the region you want to take, and go from there. And you guys are good. All right, excellent, excellent. Moving on. All right, we are doing great. All right, we've come down to our last question, everybody. The last question is talking about integral calculus. Okay, if the rate of change of a quantity is r of t equals 5t, what is the total change from t equals 1 to t equals 4? Everybody, I'm going to give you the pro tip for the test. Okay, here it is. Rate of change is the derivative. That's what they gave us. The total change is an accumulation. That's the integral. Okay, therefore, we want to know, okay, what is the antiderivative of that function given to us. Okay, so the function we want to set up is from t equals 1 to t equals 4, r of t dt. All right, which in this case is from 1 to 4, 5t dt. Okay, the antiderivative of 5t is 5t squared over 2, right? From 1 to 4, which is equal to 5 halves times 4 squared minus 1 squared, which is equal to 5 halves times 16 minus 1, which is 5 halves times 15. 15 times 5 is 75. So that is 75 over 2. And our answer is part D. And that is it, everybody. You did it. Thank you for joining me. You guys do well on your test. We'll take care. Bye.